The meeting just ended just now. Can you hear me?
Yes.
Yes, we hear you.
Hello, can you
Do
hear
you
me?
hear me? We can hear you.
Yes, we can hear you.
Maybe she can't hear us.
Mrs. Thank you. Can you hear me? Is there any problem? Mrs. Singh Hui, can you hear me?
So I'll start my presentation now. Good evening, everyone. So I'm now going to present the paper Design of a Mobile and Augmented Reality-based Indoor Navigation System. I believe that most of you are familiar with the logo or even use their services before. These are Waze and Google Maps, which provides GPS-based navigation service to navigate users from a building to another building. However, we seldom heard of commercial indoor navigation service that navigates users from a room to another inside a building. This is because GPS signals are not suitable to be used inside complex buildings such as airports, shopping malls, and university campus. Therefore, in this paper, we propose a simple and cost-effective real-time indoor navigation system with the use of built-in sensors embedded in most of the mobile devices, and with the integration of AR technology to provide an immersive navigation experience. Indoor navigation is comprised of three important components, which are positioning, pathfinding, and route guidance. At first, we will have to estimate users' position, then compute the route from user's position to the destination, then illustrate the route with directions. In order to determine which positioning technique is more suitable to this project, the popular techniques including GPS, Wi-Fi-based positioning, BLE beacon-based positioning, magnetic field-based positioning, and vision-based positioning, which can be categorized into markerless tracking and visible marker-based tracking. As mentioned in the paper, GPS signals alone is too weak to provide indoor positioning. Wi-Fi and BLE beacon signals might be affected by obstacles inside the buildings. Vision-based positioning will also be affected by light sources in which if there is a blackout, the technique will not work. Therefore, the better solution would be a technology fusion of different positioning technologies to complement each other. Based on a research found, the fusion of Wi-Fi and magnetic field techniques used in the solution provides median accuracy of 1.2 meters, which is better than solely Wi-Fi. Also, as most buildings already have Wi-Fi installed and magnetic field is natural resource, additional infrastructure costs can be minimized. However, the technique is time-consuming because it requires fingerprinting. Next, the popular pathfinding techniques include Dijkstra algorithm, A-star algorithm, and SEO algorithm. Based on the research found, A-star is more efficient than Dijkstra algorithm. However, SEO has higher accuracy and less time cost than A-star algorithm. Next, we'll discuss about the road guidance techniques. Digital map is commonly used to provide indoor guidance. However, research proves that computer graphics does not completely represent the real world, so it is difficult for users to match the map with real world. It also causes confusion because users will need to compare the actual landmark and direction with those in the map. In order to enhance user experience, AR has arisen to provide more straightforward guidance. Unlike digital map, which provides a third-person view of the world, AR shows a first-person view of target direction, which allows users to interact with the device naturally. AR is also proven to reduce the time and recognition workload of human wayfinding behaviors. Based on all this research, a simple mobile application has been developed. These are the tools used in the application. The application is built on Android Studio with the integration of Indoor Atlas SDK and AR Core SDK. As mentioned just now, the fusion of different positioning technologies provide better performance. Indoor Atlas provides last meter accuracy indoor positioning by combining different sensor sources, including magnetic field, Wi-Fi signals, and inertial sensor. AR Core SDK is then used to illustrate the road as AR images on top of the real-world camera view. This is the architecture of the proposed AR indoor navigation system. Indoor Atlas SDK will gather sensor information from the device and send it to the cloud server. Then the server will compute and return the position and route information. By using the information, AR navigation can be displayed using AR Core SDK. These are the UI design of the mobile app. So at the beginning of the implementation, a mobile app with menu screen and searching function with database storing the venue details was developed. Then the floor plans of the venue were updated to Indoor Atlas web application. After that, the point of interest and wayfinding information were added to the floor plans. Next, fingerprinting was carried out using Map Creator tool, which is the official application of Indoor Atlas. By walking around the campus to collecting location information such as magnetic field and Wi-Fi signals. After the fingerprinting process, users' position and route information can be obtained. Then the AR robot guide can be displayed and moved based on the route. So the app was tested on Sunway University campus. The campus consists of multi-floor buildings with various classrooms, offices, and facilities. So now we'll show you the demonstration video of the app. We'll use this app to guide the user to the lecture theater 6. So this is the demo of the app. A survey has been carried out to gather users' opinions toward the developed application. 10 summer university students participated in the survey. Generally, the participants have positive responses towards the developed solution. All respondents agreed with the statements that they could clearly understand the directions shown on the application. The application is helpful in guiding them to their destinations, and they will use the application in the future. However, some suggest that the AR robot guide should stop and wait for user on each node position instead of moving straight to the destination. In conclusion, the proposed system provides an immersive indoor navigation experience by using the mobile devices, built-in sensors, and AR technology. It managed to detect users' position and guide users to the destination by displaying AR navigation directions on top of the real-world camera view. The application was tested in the campus with positive feedbacks from the survey participants. Generally, all participants responded that the application was helpful to them. However, as suggested by the respondents, there are room of improvements for the AR navigation design. Currently, the developed solution works only when the destination is on the same floor as the user. Multi-floor positioning and wayfinding have already been implemented in the application, so multi-floor navigation could be achieved by just modifying the AR guidance. Finally, as this project aims to provide a simple and cost-effective AR navigation service for indoor environment, the proposed solution could be implemented in many contexts other than the university campus, such as shopping malls, airports, and hospitals. So this is the end of my presentation. Thank you.
Thanks for your
How do I
presentation. Okay,
host?
dear participants, do you have any question about this article? Okay, no question. Thank you very much for your presentation. I wish you success. Hope to see you. Mr. Sayed Amir Hussein, are you ready for your presentation?
Hello, yes, I'm ready.
Okay. You can start your presentation, please. You have 10 minutes, please.
Okay. Do you see my PowerPoint, the first page of my PowerPoint?
Yes.
Yes. Thank you very much. Good evening, everyone. I'm so happy to participate in this conference. So my presentation is about hand movement pattern recognition based on convolutional neural network and AlexNet architecture. So the number of the people with disability in the world is increased every day due to the industrialization of society. The hand is an important part of person on which daily activity depends. Various methods have been proposed to control an artificial hand. There are still many challenges in this field of artificial hand control, which can be described as high accuracy motion detection. Among the methods of the hand movement detection, the use of the EMG signal and hand image are suitable methods that can be used to detect the command to protest, robot, and wheelchair. The EMG signal can be measured in a non-invasive and invasive manner and provide us with useful information about muscle activity. Many studies have been conducted in this field, hand movement classification, and have given their traditional method to newer method. The use of convolutional neural network CNN has provided significant advance in image processing. Humans have long sought to
Sorry,
eliminate.
Said Amir Hussein.
Yes.
Please don't use full screen mode because your screen is constant. Introduction slide.
Introduction slide.
Yes.
Yes.
Okay, you can.
Yes.
You can continue, please.
Okay.
Don't use in full screen mode.
Full
please.
screen. I am in full screen mode.
Okay. You can start, please.
Okay. So CNN have many advantage in image processing, and CNN used in various fields of image processing. In this study, we use the CNN that I will explain in the next section. Um, in this study, we capture 93% hand movement image. Each person collects 6 photos in the case in 6 movement. Photos are taken with a regular phone and stored for classification. We define this movement in order to make a command for wheelchair, robots, and protests. In a section of the convolutional neural networks, deep learning has been widely studied in various fields, and for this reason, a number of regular methods have been developed with it. This method can be divided in 4 different categories. Uh, Category based on the basic mode from which they are derived, which are convolution neural network, restricted machine, autoencoder, and spare coding. You can see the classification of deep learning method in this figure. So for pre-training of the data, we use AlexNet network neural algorithm. AlexNet neural network algorithm is one of the most widely used algorithms that allow model training related to the proposed method. Using this algorithm, all images are processed and a general pre-training is performed on them. The AlexNet neural network algorithm defines the structure of the convolution neural network algorithm. The output of our method you can see in this table. That in the layer 1, we have the input image that we size it in 277 and image with zero center normalization. And at the end of the layer, layer 25, we have the output and classification, and we done it in the result section. For evaluation our proposed method to other research, we use 3 criteria, include accuracy, sensitivity, and specificity. These following criteria that we use and you see in the figure. Our results that show we can classification 6 hand movement with accuracy of 97.36%, and 93 people participate in this study that they are, all of them is a student in the college and healthy people. So the aim of this study is provide a method for hand movement classification. For this purpose, AlexNet Artichecture and deep learning neural network have been used in this research. 6 hand movements were taken from 93 healthy people in the image were the same at the beginning of the network. Its size was changed to 277, 277 and 3. And results of the classification are expressed using 5 layers of the convolution. The average accuracy, sensitivity, and specificity were in respect 94.36 and 89.96 and 90.36%. Thank you for attention.
Thanks for your presentation. Dear participants, do you have any question about the article? Okay, no question. Thank you very much again for your presentation. I wish you success in your
Thank
career.
you.
Hope to see you.
Thank you.
Okay. The other participant is Muhammed Yusuf Taha is ready. Muhammed Yusuf Taha. Umar Mahfuz Ashari is ready.
Hello, yes. Can you hear me?
Yes. Okay.
I go first.
You can start your presentation, please.
Okay. Hello, everyone, and good evening. I will share my screen. You see my screen?
Yes, we see.
Okay, today I will present to you a research regarding heart rate variability response on autism spectrum disorder and typical development children. So I am from University Technology Malaysia. Okay, the number of autism spectrum disorder children is increasing from year to year. It is stated by World Health Organization that the prevalence throughout the world population is about 2%. This is quite big for an unknown disorder. So therefore, an early detection of ASD is important as children need to get treatment as soon as possible in order to enhance the emotional, cognitive, and coping abilities for children with ASD. So when we have a early detection, we will ensure that early treatment to the ASD children will be much more effective, so that the children in the future, the children will be a functioning citizen. So thus the current method for ASD detection, firstly is observation, and secondly is checklist instrument. However, there are a few drawbacks from this method, which is the first one is subjective, uncertain interpretation, and takes longer time to work. Hence, it will lead into the delay of the child's treatment. So the current method is very slow and is very time consuming for detection of ASD. One of the reliable early diagnostic strategies is autonomic nervous system, which is biological markers that have the potential to contribute to increase efficiency of ASD assessment. ANS is a autonomic nervous system. ANS is a human body autonomous system which plays an important role in man's body regulation, mainly involving involuntary process. What is involuntary process? Involuntary process is a process that we cannot control of, such as the way our heart beat. So that ANS is classified into two different systems, which is sympathetic activity, SNS, and parasympathetic system, PNS. What are they? Sympathetic nervous system is active in response to a stressful condition that the body experiences, while parasympathetic nervous system brings back the body from emergency to sleep by reducing blood pressure, heart rate, and respiratory level. So, sympathetic nervous system is responsible when your heart beat faster, when you are scared, when you are nervous, or when you are stressed. While parasympathetic nervous system is responsible to lower those heartbeat, to lower those blood pressure, to make you more relaxed after that stressful and nervous condition. Next, how can we assess the autonomic nervous system? Based on many studies, autonomic nervous system is assessed by using heart rate variability. So from heart rate variability, we can assess autonomic nervous system, which can identify ASD. HRV, heart rate variability, HRV, is an effective and complex tool for studying the relationship between sympathetic and parasympathetic nervous system. It is also known as autonomic equilibrium between SNS and PNS. So here is the example of HRV signal. The HRV signal we will use and analyze it. Here you can see the frequency domain analysis, time domain analysis, time frequency analysis. So from this analysis, we can extract some feature from this analysis. Objective of these studies is to investigate the heart rate variability response between autism spectrum disorder ASD children and typical development children. HRV can be derived from so first of all we gather 20 participants, 6 from autism and 14 from normal people. HRV can be derived from PPG and ECG. For this study, we use PPG as it is more suitable to be used to ASD children, as PPG is smaller and not bulky compared to ECG. So PPG is smaller for autism for ASD children. This PPG is more desirable for ASD children and easy to use for them, and it is more more comfortable for ASD children to use compared to ECG. ECG is too big for them, and it will make ASD children more stressed. Subjects were between the age of 8 and 12, including both sexes. All the ASD children who participated have been certified and diagnosed by medical doctors. So before we conduct the testing, we make sure that all the ASD children is certified by medical doctor. Firstly, we'll record the PPG, and then while we will record the PPG, while conducting baseline test and color stimulus test. Baseline test is a test when the subject is in a relaxed condition, while color stimulus test is a test that when the subject responds to a stimulus. For the extraction of the HRV feature, 3 methods of signal analysis are used, which are time frequency and time frequency while selecting the relevant HRV feature is performed using AUC feature selection. Finally, the selected feature are tested and compared using classifiers, which is support vector machine and shallow neural network. The result here, wherefore, as we conducted 2 tests, which were color stimulus test and baseline test, we found out that the only significant difference that is shown is on the relaxed condition, which is in the baseline test, whereas there is no significant difference in color stimulus test. In conclusion, HRV obtained from PPG signal are able to differentiate between ASD and children and TD children. Our findings that indirectly show that parasympathetic and sympathetic activity for TD children were different from ASD children during resting state condition. I think that's all from me. Thank you. Hello. Hello, that's all for me. Thank you.
Can you hear me? Okay. Mr. Timothy Ganim, are you ready?
Yes.
Okay. Sorry for this problem.
So let me share my screen.
Okay.
Is it okay if I okay, let me switch the presenter and slides. Okay. So and this in our article we discussed a model-based approach to assist Android developers when they develop Android Activity Lifecycle. Okay, so briefly in this presentation, we're going to walk through what is the Android lifecycle model, activity lifecycle model, and issues with the activity lifecycle model development from the literature. What's our research overview, and then we go for the literature, see what's in there, then discuss our approach and how we evaluated it and results that we had and the conclusion. Finally, we discuss next steps, right? Now, this is the Android Activity Lifecycle model that exists on the Android developers reference page that all Android developers have to be acquainted with and know how to properly implement and handle the state transitions between the different states that the Android activity has to go through. All right. Now, the conformance to this model has been proven in the literature to have problems. Previous researchers have proven that there are many problems with Android developers implementing activity lifecycle that conform to the model. You know, a spread of memory leaks, app crashes, so on and so forth. All right, so there are so many issues in the literature related to implementing this model. So our research problem was focused on, actually we have a fact in the literature that the activity lifecycle model is intimidating even for a seasoned developer. And to the best of our knowledge, we couldn't find any state-of-the-art Android development tool or IDE that help Android developers during development, at development time, do a better Android Activity Lifecycle implementation. All right, and we thought of presenting another view, and then I'll come to discussion of the view. Why did you use the approach of a view and not any other kind of approach? And so we thought about using a view to help Android developers do a better implementation. So these are the two pillars of our research. So the issue with the view is this is the default view that any Android developer has when developing any Android activity. They have the Android manifest file where they see all the registered activity in the app, and then on the right, this is the actual activity file where all the callback methods for the state changes are implemented. This is the default view that all Android developers know and see day to day. All right, and this is where the problem lays. This is where the literature has proven that there are problems with people implementing those lifecycle callback methods. All right, so our objectives were on the research to develop a model, two domain specific languages. One is visual and one is textual, and then use that to enable a multi-view approach that presents another view in addition to the default one to Android developers to help them implement a better Android activity lifecycle. And then we wanted to evaluate the effect of this approach on real Android developers. Now, more formally, we stated in our article that we have two research questions that we're intending to answer. One is how can a model-based approach assist the activity lifecycle development, and the effect of a multi-view solution on Android developers. All right. Now I'll jump real quick to the literature. We did a literature survey to see what people actually have done in the past to assist in Android application development. Now, one of the major fields is model-driven development, where there is a model, whether it's a visual or textual model, that a modeler or developer uses to generate the end product. Now, these approaches do not help a lot because once you want to do refactoring on the code, you have then to go back to writing manual code, and the model approach is not useful in that case. So there is no real solution to the lifecycle problem. The second kind of group in the literature are tools that do security analysis, and we have found that mostly those are post-development. They provide post-development support and not at runtime, or not at development time. Sorry. Another group of approaches do testing, allow for Android app testing, and again, we didn't find a development time support kind of a tool. They were all post-development, or even not only post-development. They operate on apps that are even deployed or published on the app stores. And there are other kinds of approaches that we've seen, those that help develop tools for developers. We found one that was very close to ours, to what we were thinking, which is a life cycle conformance checking tool, but we didn't find any integration support with an IDE, so it's effectively doesn't help. All right, so the gap for us was clear that there is no state-of-the-art tool that can help developers do their activity lifecycle development at development time, neither post-development, neither where the app is on the cloud. Now, going back to why we have chosen a view-based approach is because it has been proven again in the literature that view-based approaches are beneficial mechanisms for addressing specific and multiple concerns during app development, and it actually reduces the development complexity that exists in the code that is low level, that contains so many details that the developer has to pay attention to. So seeing a visual view has been proven again in the literature to have is beneficial. All right, so now this is a generic overview. This is a theoretical overview of our approach, we have two main domain-specific language. One is textual and one is visual. And then we have three major components. One that actually reads and parses the Android activity code file, converts it into an instance of the domain-specific textual language code. Another one that converts the DSTL to the visual language code. And finally, another final component is takes the visual language conforming code and presents it as a view. Now, this approach has been implemented as an Android Studio plugin for people to download and use in so for Android developers to download and use in their development. This is how it looks like in Android Studio. Here's another one, and finally this is the full view, and you can see that the view is progressive. A developer can open nodes and close nodes, and so that the view can be specific to one callback method or another. All right. To evaluate our approach, we have performed a case study in 4 steps. We have recruited real Android developers, have them participate in a session to learn about how to use the Android Studio plugin. Then we ask them to develop an Android app, and finally fill a survey to capture their satisfaction, how they felt about using the tool. We were able to recruit 6 developers, and in our case study. Now the results, as we've seen them, most of the developers tend to agree and strongly agree with the approach and our tool. But we have seen that in one of the answers to the survey questions, we've seen that the results were not fully balanced. So the results were not leaning towards the agree side. So we wanted to investigate more. And so we asked the developers 2 open-ended questions about what issues did they find when using the plugin, and what would they suggest should be made to make the plugin a better solution. And what we concluded from their answers is that the concept was useful, but in order for such an approach to be endorsed and adopted fully by Android developers, it had to contain many features and options and be bug-free for them to endorse it fully and use it in their apps. So these are the 2 main conclusions that we draw from our research. And looking forward, we did our research on 6 Android developers on a loosened kind of environment where we actually kept the participants as incentivized as possible to make sure that they can finish the case study. So we highly recommend that we reapply the same evaluation procedure that we did, but in a broader scope, where more Android developers are involved, and the development environment is a more realistic one than the one that we used. So that's all there is.
Okay, thank you very much for your presentation.
Sure.
Dear participant, do you have any question about this article? Okay, no question. I wish you continued success in your career. Hope to see you, Mr. Timothy Danin.
Thanks.
Okay. The next paper is belong to Todorov. Todorov is ready. Mr. Todorov is ready. Okay, Muhammed Yusuf Taha is ready. Muhammed Yusuf Taha is ready. Mr. Todorov is ready. Okay, except for these two papers, all papers have been completed. I am waiting for a while for these two papers.